Hello, welcome back. Today we're going to do a case study on a vehicle I dealt with. It's a Honda CRV 2019 with the AC not working. On one of our previous videos we talked about relays, how they function electrically, what they look like in a wiring diagram. So we're going to talk about how we diagnose them in an actual vehicle. So I've taken the main parts of the wiring diagram that matter in this case. The story is with this one, it's a 2019 Honda CRV. It had a leak in the evaporator. The evaporator was replaced, system was recharged, AC didn't work afterward. Now we got a problem. What do we do next? Well, we're going to go and figure out why. So we look at the AC. The AC compressor is not coming on. The clutch isn't turning. Why is the clutch not turning? The easiest way to start looking at the problem is by finding the AC compressor clutch relay, which was located in the underhood fuse block. I tested for power at the two pins. The control pins are always the small pins of the relay, and the larger pins are the controlled pins that do the actual load of the circuit. So we had power from the ignition fuse, power from the engine bay fuse, which is part of the same fuse block. So that was all good. The relay is getting powered. When power was checked on this pin, on the large pin, a ground signal was seen. You could, when you put an ohm meter on it, we could see the resistance of the clutch. But when measuring the small pin of the control side of the relay, nothing was measured, which means the ECM, when we look at the wiring diagram, ECM was not controlling the relay to close, and therefore no action from the compressor. Question was why? So we end up going old codes. We had a P0532. It was an open on the pressure, AC high side pressure switch. So the AC control unit is not seeing the right pressure, is telling the ECM, I'm not working right, what's going on? That's why we're not getting a closed relay. So we found the switch. It was just a 3-wire sensor. Had 5 volts in, ground, and signal. One of the wires was broken, and that is why we had no function. After the wires were repaired, the ECM was getting signal from the AC control unit, close the relay, and turn the compressor on. Some of the other lines that we can see here on the diagram, this is not the full diagram. The full diagram is actually 5 separate pages. I've condensed that for simplicity. So the AC compressor had 3 wires coming out of it. One to control the magnetic clutch. The body of the compressor itself is a ground. So basically the aluminum body of that compressor is ground. Pretty common for something like a compressor, an alternator, a starter motor. The other 2 wires are the variable displacement control wires from the AC control unit. In a more modern TXV thermostatic expansion valve system, the AC compressor will vary its active displacement in order to keep the air conditioning running all the time when it's commanded on, but only the amount that it needs to be. An older system, there used to be a cycling clutch orifice tube. We're going to do another video on air conditioning, but basically you would just have a wire to the magnetic clutch. it would snap the compressor clutch closed. You could hear it and hear the motor RPM come down. And it runs the compressor until the high side switch is happy. It sees too much pressure, then it shuts the compressor off and it just cycles. And then we just have a pair of data lines, just CAN bus, and allowing the AC control unit to talk to the ECM. Those are all the wires that really mattered in this wiring diagram. The rest of the other pages were not really relevant to this problem. So when you're taking a problem, it can be a comeback, it can be a new problem. I always like to start at the relays. What's the relay doing? How are we going to deal with the problem? What's being controlled? Because the relays are kind of the midpoint of what's being controlled and how is the computer controlling it, and how can we output it. One thing we could have done, but it can be dangerous if you don't know what you're doing, is we could have manually applied power to this pin and forced the clutch to close. Probably would be better to do it with the engine not running and just watch for the clutch gap to close or listen for it. Then you can know the clutch is working and it's not an issue with that side of the relay. With the output side, it's a problem with the control low current side. So when you're diagnosing, always consider, if you don't know where to begin, find a relay, split it in half. Is it the control side? Or is it the output? The same can be said about like a horn circuit. A horn circuit is a very good example. You can get rid of all of this and think you have a switch to the horn pad, and this side would have the horn itself, because the horn would be a high current load, and the switches want to see a low current load so they last longer. Thanks for watching. We'll see you in the next video.